Consider the airplane. It's a magnificent machine, isn't it? These metal birds allow us to soar through the clouds, visit family across the country, and explore amazing new places all over our planet. For decades, we've relied on jet engines to get us there. A jet engine works by sucking in a huge amount of air, squeezing it, mixing it with fuel, and then setting that mixture on fire. Boom! The hot gas blasts out the back, pushing the airplane forward. It's a powerful and proven technology, a real marvel of engineering that has made our world feel smaller and more connected. But there's a big problem with this way of flying. The fuel that these engines burn is a fossil fuel, like kerosene. When it burns, it releases gases into our atmosphere, including a whole lot of carbon dioxide, or CO2. This is a greenhouse gas, which means it traps heat and contributes to climate change. The aviation industry is a major source of these emissions, and as more and more people fly every year, the problem gets bigger. We love to fly, but our high-flying habit is adding a lot of pollution to the air we all share, and that's a serious issue for the health of our planet. To solve this problem, brilliant scientists and engineers around the world are racing to find cleaner ways to fly. Some are looking at using hydrogen as a fuel. Hydrogen is great because when it burns, it only produces water. But storing hydrogen on an airplane is tricky and expensive. It needs to be kept super cold or under very high pressure. Other engineers are trying to make airplanes that run on batteries, like a giant electric car in the sky. The trouble is, batteries are incredibly heavy, and they don't store enough energy to power a big plane for a long flight. So, the challenge is huge. We need a new way to power our planes that doesn't create harmful pollution, doesn't require carrying complicated fuel, and isn't too heavy to get off the ground. It sounds like something out of science fiction, doesn't it? Well, science has a way of turning fiction into fact. What if we could build an engine that didn't need any fuel at all? What if it could just use the air around it and a little bit of electricity? That would be a game changer for aviation and for our world. And that's exactly what some very clever people have been working on. A new kind of engine. Get this. A team of researchers in China, led by Professor Jau Tang at Wuhan University, has built something truly remarkable. It's a prototype for a jet engine that doesn't use a single drop of fossil fuel. That's right, zero fuel. Instead, it uses two things we have plenty of: air and electricity. This incredible invention could completely change the way we think about flying. The engine works by taking in the air from the atmosphere, just like a regular jet engine does. But that's where the similarities end. It's a whole new kind of science in action. Instead of mixing the air with fuel and creating a fiery explosion, this engine uses microwaves. Yes, microwaves, just like the ones in your kitchen oven that heat up your popcorn. The engine compresses the air it pulls in and then zaps it with powerful microwaves. This process is so energetic that it transforms the air into a special superheated state of matter. This new substance is then blasted out of the back of the engine, creating thrust that pushes the engine forward. It's a clean and elegant way to create motion without any combustion, which means no fire and no polluting exhaust. The initial results are incredibly promising. In their laboratory, Professor Tang's team built a device that used this technology. They were able to generate enough thrust to lift a 1 kilogram steel ball, which is about 2.2 pounds. Now, that might not sound like enough to lift a giant passenger plane, and you'd be right. But think about it. This is a brand new technology. The Wright brothers' first flight only lasted 12 seconds and didn't go very far, but it proved that powered flight was possible. This test proves that fuel-free jet propulsion is possible. This achievement is a huge step forward. For years, scientists have dreamed of creating propulsion systems that work within our atmosphere without burning fuel. This plasma jet engine is the first of its kind. The team in China believes that with more development, they can scale up the technology to produce thrust that is comparable to the conventional engines we use on commercial airplanes today. Imagine an airplane that silently glides through the sky, its engines glowing with energized plasma instead of roaring with fire, leaving nothing but clean air behind it. That's the future this invention makes possible. So, what is this magical stuff that the engine creates? It's called plasma. You might have learned in science class that there are 3 states of matter: solid, liquid, and gas. If you take a solid like an ice cube and add energy, heat, it melts into a liquid, water. Add more energy and it turns into a gas, steam. But what happens if you keep adding even more energy to a gas? You get plasma. Plasma is often called the 4th state of matter. It's what you get when a gas becomes so hot and energized that its atoms start to break apart. When you zap a gas with enough energy, like with powerful microwaves, the electrons are stripped away from their atoms. This creates a mixture of free-floating electrons and positively charged ions. This superheated electrically charged gas is plasma. It might sound exotic, but it's actually the most common state of matter in the entire universe. The sun is a giant ball of plasma. The stars you see at night are plasma. Lightning is a streak of plasma cutting through the air. Even the beautiful northern and southern lights are created by plasma in our upper atmosphere. What makes Professor Tang's work so special is that his team created a stable jet of plasma at normal atmospheric pressure. Usually, it's easier to create and control plasma in a vacuum, which is why organizations like NASA have used similar ideas for spacecraft engines designed for the emptiness of space. But making it work in the thick air of our atmosphere, where it can be used to power airplanes, is a monumental breakthrough. It takes an incredible amount of focused energy to turn regular air into a plasma jet that can produce thrust. This is the secret sauce of the new engine. By turning plain old air into a powerful, high-temperature plasma jet, it generates force without needing any onboard fuel. The engine essentially uses the atmosphere itself as its fuel source, converting it from a simple gas into an energetic plasma state and then expelling it. This process is what creates the push, the thrust, that can move an aircraft. It's a brilliant application of fundamental physics, taking a principle we see in stars and lightning and harnessing it for clean transportation right here on Earth. Now, before we get too excited and start looking for plasma-powered flights for our next vacation, it's important to remember that this technology is still very new. The biggest challenge it faces is its enormous appetite for electricity. Creating and sustaining a powerful plasma jet requires a massive, constant supply of electrical power. The prototype in the lab was likely plugged into a powerful source on the ground. To put this engine on an airplane, you'd need an incredibly powerful and lightweight power source on board the plane itself. That's a huge engineering hurdle we still need to overcome. Where would all this electricity come from? The dream is to power these planes with clean, renewable energy. Perhaps future planes could have advanced solar panels on their wings, or maybe we'll develop compact nuclear fusion reactors, tiny stars in a jar, that can generate the needed power without emissions. These power sources don't exist in a practical form for airplanes just yet, so a lot more science needs to be done. Scaling up the prototype from something that can lift a steel ball to an engine that can power a 200-ton jumbo jet is a long journey that will require years of research and development. However, the advantages of this technology are so great that it's worth the effort. Consider the alternatives. Hydrogen planes would require a whole new global infrastructure for producing, transporting, and storing the fuel. Battery-powered planes are limited by weight and range, making them suitable only for short trips. This plasma jet engine, on the other hand, wouldn't need any complex fuel storage at all. If we can solve the power supply problem, it offers a much cleaner and potentially simpler path to zero-emission aviation, for both short and long-haul flights. This invention represents more than just a new engine, it represents hope. It's a proof of concept that shows a radically different future for air travel is scientifically possible. It inspires us to push the boundaries of what we think is achievable. The journey from a laboratory prototype to a fleet of commercial airliners will be long and full of challenges. But every great leap in science starts with a single bold step. Professor Tang and his team have taken that step, lighting the way toward a future where we can soar through the skies without leaving a trace, exploring our world while also protecting it. The age of clean flight is getting closer. Consider that.